Okay, let us discuss this problem. First draw the figure, the top figure, and the bottom is just for understanding purpose. And this is from 1.257 Irodov. So let us draw the figure and then we will discuss the problem. Now what the problem says, it says a spool with thread bound on it of mass m. So the mass of a spool, so this is a spool. So mass of a spool is m. This is given in the problem. And there is a thread, so this is the thread that is bound on it, and this goes something like this. So thread makes an angle alpha with respect to the horizontal. Its moment of inertia relative to own axis is given by, so moment of inertia of a spool is given by I is equals to, and this is given gamma times mr a square. So let me put capital R, otherwise I will have confusion. So let us put capital R. So gamma times, so I is ICM, of course this is about center of mass, about this axis, gamma times mr square. This is given. Now let me take what is a spool. Have you ever seen something, a spool kind of thing? This kind of, you maybe have seen in your kitchen that is used to make the rotis. Something like this. That is called in Hindi, we call it belna. So belna. So this is something like belan. So in Hindi we call it belan. So you see, belan is a kind of a spool. So you have some threads there, or you may have you have seen kites, a spool where we have kites. So this is the where we are having threads. Now this thread is angle of alpha. Now the question says its moment of inertia related to own axis is I is equals to gamma mr square, where gamma is a numerical factor. Sometimes this is also called radius of gyration. R is outside radius of a spool. So this R is outside radius. So this radius is R. And the inside radius is a small r. So inside radius of a spool is a small r. So let me put the small r in place of a small r. Let us call this is a small a, so that I don't have any confusion. So inside radius is a small a. The spool is pulled without sliding. So there is no sliding. So pure rolling. So this is a case of pure rolling. That is, this means V is equals to R omega. So this is a case of pure rolling. So this is a case of pure rolling. So V is equals to R omega. Situation is V is equals to R omega. Find the, so constant for F, find the projection of acceleration vector of a spool axis on the x-axis. So this means I have to find the acceleration of this point, this axis, with respect, this in the x direction. So we have to find AX. This is fairly easy problem. You see what will happen. This spool will be pulled by this thread. If this thread pulls this spool this side, so I can assume this is going this way, but this is now, if this is a force, so let us say what will be the motion. I will make the spool here. Now this is the spool. Now I can assume this is going in this way because the force is acting. So let us assume acceleration of center of mass in this direction, A in this direction. Once again I will have a confusion with acceleration and A. So let us call this acceleration as what we call, let us call this acceleration is what we can take. So let us call this acceleration is A1. Now acceleration is A1 of center of mass. Now this can go in this direction and this can roll also. So let us assume this is rolling in this way. So this is unbinding. So there is a force also acting here. This force F. Now since this is a case of pure rolling, there will be a friction here. Now it is, I can have friction either in this direction or in this direction. It will not matter. Let us take any direction. What direction you want? Either this direction or this direction. This direction. Okay, so let us assume or this direction. You see, this is a static friction. The point of contact will have a zero velocity, so a static friction direction we cannot find by using law of relative. So if there is nothing relative motion, so we cannot find the static friction. So let us assume this friction is in this direction. Now let us write the equation of motion. So this angle is alpha. So translational equation I can write. So I can write translational motion equation. So F cos alpha in this direction, F cos alpha minus a small f is equals to mass into acceleration. This is the first equation I will get. F cos alpha. Now if I write a vertical direction equation, I am not going to get anything, because a normal reaction will come into picture. That is, I will get one other unknown normal reaction. So there is no point of the writing the equation in vertical direction. Let us write torque equation. So if I see this force F cos alpha, and in this direction F cos alpha, and F sin alpha will go something like this. So torque of this is simply F cos alpha into this small distance A. So torque will be, because F sin alpha will pass through the axis. So torque, so let us write rotational equation. So if I write rotational equation, what I will write? F cos alpha, this is the force in this direction, into A, that is the radius, force into displacement is equals to I alpha, and I know that is gamma times mr square I into alpha. This is the second equation I will have. Now I also have A is equals to R alpha, because this is a pure rolling. So at this point there is a pure rolling. So you see, at this point I have A alpha, that is in this direction. Oh my god, R alpha. So A alpha, that is moving in this direction. So alpha in this direction and A1 is also in this direction. That is not true. I cannot have both in the same direction if the pure rolling. I have to have this alpha in this direction. This should move in this direction. Then only I can have R alpha in this direction and A1. So I have to take motion in this direction. Then only possible. Because at this point, so if I say, let us call this point A. So if I see point A, in this direction we will have this distance R into alpha. In this direction I will have the acceleration of center of mass, that is A1, because this point will have two acceleration of center of mass in this direction and R alpha in this direction. So A1 is equals to R alpha. So this is equation number 3. Now you see, in this case torque is equals to I alpha. I have to take the torque of friction also, that we have missed. So torque of friction is F times this distance, that is R. Now this torque will rotate in this direction, so this is positive. But this torque will rotate in this direction, this is negative. So F into R minus. Are you getting or not? Because we have changed this direction of rotation, so I have to make minus sign here. Now we have three equations I have to solve for. So I have unknown F, I have unknown A1, and I have unknown alpha. I can solve for FA alpha. So let us solve for A1. So how can we solve for A1? So if I divide the equation 2 by R, so equation 2 becomes F minus F cos alpha A by R is equals to gamma mr alpha. So equation 2 is now this. If I divide by R. Now I need F cos alpha. Equation 3 is equals to A1 is equals to R alpha. Now if I put this here, in equation 2, A1 is equals to R alpha. So equation 2 can also be written as F minus F cos alpha A by R. R alpha is simply A1, so this is A1. Equation 2 can be massaged something like this. Are you getting or not? Now, if I add the equation 1, that is F cos alpha minus F is equals to MA1. Now, if I add these two equations, what we will get? we will get f cancels out. So this is equation 1, this is equation 2 in a new form. So f, if I take common, this becomes cos alpha is also common. So 1 minus a by r, this is equals to, if I take m common, 1 plus gamma a1. So from here I can write a1 is nothing but f cos alpha by m, f cos alpha by m into 1 minus a by r divided by 1 plus gamma. This we will get. So let us just copy this one. Basically I have done one mistake. Where is the mistake? You see, let me see where is the mistake. Now the mistake is, you see this force is acting tangentially. So what is the distance from here? This distance is a. So what is the torque? Simply F into a. There is not a torque F cos alpha into a. So F into a is the simply torque. So you see, I have to have a modification. There is no cos alpha because there is no torque of cos alpha. So simply F cos alpha. So this cos alpha goes. Now this cos alpha in equation 2 will goes everywhere. So this is equation 2. This cos alpha goes. This cos alpha goes. Equation 2 cos alpha goes. So now I will have simply F. Now a by r, no cos alpha, but here I have cos alpha. So this will become, so this cos alpha goes, and here I have cos alpha. So finally this cos alpha goes. Are you getting or not? You see, this cos alpha will go. So this means here I will have, if we add, you will get the same thing. This cos alpha goes, here I will have cos alpha. You verify yourself. I will wait for 1 minute. Whether are you getting? So only thing is the force torque I have taken, that is wrong. You check yourself, you will get the answer, no problem. Now let us discuss the next part. So this problem has a second part. So what the second part says, so part B is asking kinetic energy. Okay, let me see. Part B is work performed by the force. So force, what is the work that is performed by the force? So we have to find out the work done by the force. How we will find the work done? So and this is work performed by the force during first t second after the beginning of motion. So after t second. So if I can find what is the distance traveled by the projection point of application of the force. So you see, point of application is here. Now if I somehow I can find what is the distance traveled by the point of projection, and then we can find. So now you see, so this means I have to find what is the acceleration of this point, and acceleration of this point and acceleration of this point will be same, because whatever the acceleration here we have will be the have same acceleration. So you see, only thing is direction will be different. So what can I do is, I can take displacement acceleration, I can find acceleration of this point, and then I can find the distance traveled by the point of projection. Or I can do one more thing. I can find what is the acceleration of this point, and then I can multiply by f cos alpha, because point of projection in this direction will have only f cos alpha force, and in this direction f sin alpha, that is a point of projection is moving in this way, but this is its force in this, so I have to multiply by f cos alpha. So what is my target is? So my target is, so let me see here. So I will have this. I will find what is the acceleration of this point, and then I will multiply by f cos alpha into ds. Now find a acceleration, and s I can find using initially 0 velocity plus half a t square. Let us say this point is a, so acceleration of a into t square. This will go displacement. So work done is simply f cos alpha into s. So my only concern is to find out the acceleration of point A. Now you see, if you see this figure, the previous one, Now acceleration of point A will be, so this point, now I am considering this point, let us A, or let us call this point P, because A I have already used. So this point is P. So I can find, so this point is P. So I can find, so you can change your language, this point P. So I can find what is the acceleration of point P. So acceleration of point P is center of mass has acceleration A1 in this direction. So this point P will also have A1 in this direction. So point P will have acceleration A1 in this direction. And you see center of mass has acceleration. So rotation is in this, so A alpha. So radius of this into alpha in this direction. So radius is how much? Radius is a small a. So A1 into alpha, this is in the opposite direction. So you will have a A1 into alpha in this direction. Oh, sorry, A into alpha. Are you getting on? So total in this direction, what is the acceleration? A1 minus A alpha. Now we see, you see, we have already found what is A1. A1 is nothing but, you see the previous problem. So let me write here. So A1 is, so this acceleration A1 is F by m cos alpha minus A by r and 1 plus gamma. So this is A1 minus A alpha. A alpha is the, and alpha, what is alpha? Alpha is, I can find using this equation, what is alpha? Alpha is A1 by r, capital R. So A1 by capital R. Now even if I have not put this number, I have got the better result. So let us calculate. So this is my A1. So this whole term is A1. And this is A1 by A into A1 by R. So if I take A1 common, I can do better. A1 common, so what will happen? 1 minus A by R. And A1 is what? A1 is this total number. So F by m cos alpha minus A by R by 1 plus gamma, and this is A1 is this, into 1 minus A by R. So this is the acceleration of this point. So what is the distance traveled? That is half A1 t square. So this is the half A t square. So this is half F by m cos alpha minus A by R divided by 1 plus gamma, and this will be into 1 minus A by R into t square. This is F. A speed, a distance travel. So what is work done? Work done is F cos alpha into S. So this will become F square by 2m cos alpha into cos alpha. Now this is the simply mathematics. There is no physics here involved. 1 plus gamma and 1 minus A by R t square. So this is the work done involved. Check yourself whether are you getting the same answer or not. Okay, now let me see the answer with